Hi. Today we are going to see how to find out the block, period number and group number of a given element from its electronic configuration. So let us straight away start with an example. We'll be finding out S block, P block, D block, F block, which block it belongs to, and accordingly how to know what is the period number, group number, etc. Let us take element with atomic number 11. I'm not writing which element it is. Let's find out which block, period, group, etc. it is. First of all, let us write its electronic configuration. According to Aufbau principle, when you distribute the electrons in the increasing order of energy, it is 1s2, 2s2, 2p6, 3s1. You can see when we distributed the electrons, the last electron enters S subshell of the valence shell. Therefore, it is S block element. Clear? It is S block element. Now, what about the period number? Period number means the outermost shell number or the highest principal quantum number. You can see the highest principal quantum number or outermost shell is 3 here. So, period number will be 3. Clear? It is in the third period. Now, what about the group number? If you want to know the group number, to find out the group number, the rule is different for different blocks. For S block elements, the group number is the number of valence electrons. Number of valence electrons. So, how many valence electrons are there? Only one valence electron in the valence shell. So, it is 1. So, we come to the conclusion that this is S block element belonging to third period and it is in group 1. Now, you know it is sodium. It is 281. It is in the third period, then group 1 and it is S block element. Clear? Now, let's come to another example. Let's take atomic number 70. First of all, you write the configuration. 1s2, 2s2, 2p6, 3s2 and 3p5. You can see we have given the last electron into the p subshell of the outermost shell. Therefore, it is P block element. Clear? Now, what about the period number? Same rule. You can see the outermost shell is the third shell here. 3s2, 3p5 both are a part of third shell. So, outermost shell number is 3 or highest principal quantum number is 3. Therefore, period number is again 3 here. Now, let us find out what is the group number. The rule for P block group number is equal to 10 plus total valence electrons, that is Ns electrons plus Np electrons, which represent total number of valence electrons. Here, total number of valence electrons, how many are there? 2 plus 5, 7. So, total 7 electrons in the outermost shell. So, total valence electrons 7. That is Ns electrons 2, Np electrons 5. So, it will be 10 plus 2 plus 5. It is in group 17. So, this element is in group 17. Now, what is the location of this element? It is a P block element belonging to third period and group 17. You know its chlorine. Clear? Now, let's take another example. Atomic number 24. Let's write the configuration. 1s2, 2s2, 2p6, 3s2, 3p6, Then you know it is 4s2 and 3d4, but rearrangement for stability, half filled and completely filled configuration stability. So it was 4s2, 3d4. You will rearrange it into 4s1, 3d5 for stability. But let us rearrange in increasing order of shell number. If you do that, it will become 1s2, 2s2, 2p6, 3s2, 3p6. It will be 3d5, 4s1 because fourth shell is the outermost shell. That is how it exists. So arranged like that. Now, coming to the block of this element, you can see, don't look at this for block. When you wrote the original electronic configuration in the beginning, before you rearrange for stability, the last electron was given to D subshell of the n-1 shell, penultimate shell. So, since the last electron goes to D subshell, it is a D block element. Clear? Now, coming to period number. Period number, you can see the outermost shell. If you don't rearrange this, you might go wrong because you might think 3 is the outermost shell as per what you have written. But fourth shell is there. So 4 is outer to third, right? So the fourth shell is the outermost shell. Highest principal quantum number is 4. So it is in the fourth period. Now coming to group. What about the group of this element? For D block elements, the rule is group number is n-1 d electrons plus ns electrons. n-1 d electron, how many? 5. If this is n, this is n-1, right? Ultimate and penultimate shell. So, n-1 d, 5 electrons, and ns, it is 1 electron. So, it is in group 6. You know, it is chromium, you can check. It is a D block element. It is in fourth period and sixth group. Clear? Now, so we have already discussed S block, P block, and D block. Now, let's come to F block. F block, we are not going to do any such calculation. We can get it very easily. That is, you know, all F block elements, they belong to group 3. So, no need of any calculation. They are all in group 3. Right. And what about their period number? Period number, we can use this trick. That is, if the atomic number of the given element is between 58 and 71, 58 to 71, they are lanthanoids. They all belong to 6th period. So, you just check the atomic number. If it is in this range, then it will be a lanthanoid and that will be in 6th period. And if the atomic number falls in this range, 90 to 103, they are all actinoids and they all belong to 7th period. So, very easily, you can arrive at the group number and period number of these F block elements, which are inner transition elements. Clear? So, I think you all got it clearly. Just practice. You can do such questions easily using this technique. Okay. Okay then. That's all for today. And like, share and subscribe to my channel and wait for more videos, which will be definitely helpful.